Hey folks, welcome back for another episode of Code Club. I recently stumbled upon this figure and I noticed something in it that I never see in plots generated by ggplot2. And I wondered, why? Why don't we see those in plots generated by ggplot2? Do you see it? Do you see what we don't typically see in these types of plots? Well, if you're like me, you noticed these tick marks on the log y scale of these four figures. That normally we don't see minor ticks in ggplot2. You can certainly do that, and we certainly don't see them on a log scale. I think on a log scale, they're pretty helpful because I know that typically this line would be 1, 2, 3, 4, 5, and you can count up to 10, and that it then cycles over, right? So in today's episode, I am going to show you how you can make these graduated log-scaled minor tick marks on the y-axis, and if you had another plot that needed on the x-axis, you could do the same thing for the x-axis. So that figure comes to us from a paper published in the journal MBio, which is the flagship journal of the American Society for Microbiology. Paper's titled A Molecular Comparison of Iron-Sulfur Cluster-Based Homeostasis in Escherichia coli and Pseudomonas aeruginosa, published by Alessandra Lo Scutio, sorry for the pronunciation, and colleagues. And the figure that, again, caught my eye was down here in figure 2. I think it was one of their sub-panels. Yep, panel 2C. And what this paper was doing is looking at a gene that regulates iron cluster synthesis, as I understand it. This is not my area of research, so forgive me if I don't get it all perfectly right. They were looking in Pseudomonas aeruginosa, which is a pathogen that infects people with cystic fibrosis and other lung problems. It's a real nasty bug that tends to become resistant to different antibiotics. And so what they found was that when Pseudomonas aeruginosa is exposed to different antibiotics, it is sensitive to those antibiotics, so like gentamicin, ofloxacin, meropenem, and colistin. But if you knock out the gene related to the iron-sulfur cluster, this ISCU, then it becomes resistant to at least 3 of these 4 antibiotics, okay? And so that's enough of the biology, but what I want to do with you today is see about regenerating this figure C. I presented this figure in my newsletter back in October. The paper was published at the beginning of October, and I think I shared maybe the middle to end of October in my newsletter. If you want to see that newsletter email, by all means, go down below in the description to this video. You'll see a link to that email, and you can kind of get my 30,000-foot view thoughts on the figure and kind of how I would go about building it, which is exactly what we're going to do today. All right, so I have some simulated data here. I'll go ahead and load the tidyverse, set my seed, and then generate this table, which is quite big, but it's Fig2C data, and it has 5 columns. So the drug, the gentamicin, the colistin, whatever it was, one of those 4, the strain, PA01, is the wild type, and then there's a knockout, and then there's a knockout that's then been complemented to have that gene function returned. We're told in the legend of the figure that they did triplicate for each of the conditions, so we have 3 replicates. There were 4 time points across the x-axis, 0, 1, 2, and 3 hours. We also then have the density of bacteria that were still alive at those different time points, again, for the 4 drugs and the 3 different strains. So I'm going to see about building one figure at a time. I think I'll first generate one figure, and then we'll build a function to replicate that for the 4 other drugs. So let's go ahead and take Fig2C data, as we've already seen, and let's go ahead then and pipe this a filter to get drug equals gentamicin. And so that didn't give anything back, and that's because I misspelled gentamicin. So G-E-N-T. All right, there we go. Now we have 36 rows. Again, 3 strains, triplicate, and 4 time points. That gives you 36 conditions. I then want to summarize those 36 values to get, for each strain and each time point, an average and a standard deviation density. Again, the legend told us that the values presented were the mean plus or minus 1 standard deviation. Okay, so what we can do in here then is summarize, and we'll do mean equals mean on density, and then SD will be the SD on density, and then we need to tell summarize what to group by. So we'll do dot by, and we'll give it a vector of columns to group by. So we'll group by the strain and the time. And so then this gives us, if we can see it, we've got our 3 strains in the first column, our 4 time points, and then the mean and the standard deviation. Previously, a couple years ago, say, you might do the same series of steps doing group by and then summarize. So in the last year or so, a new version of dplyr came out that allows us to use this .by argument. I find this far preferable because if we were grouping by 2 variables, the output of all this would be grouped by one of those variables still. And as you can see, running it this way, there is no grouping of the outputted summarized data. So that's great. So let's go ahead then and pipe this to ggplot. And our aesthetics on the x-axis, of course, we'll put time. On the y, we'll put the mean. Color, we'll do the strain. And then we'll make this a line plot. So we'll do geom line. So sure enough, we now have our line plot. It is on a linear scale. It's not log scaled yet, but we'll get there. Don't worry. One thing we're missing from this are the error bars. So let's go ahead and add that in. And so here I'll do y min equals mean minus SD. Again, remember it's plus or minus the standard deviation. And then y max is mean plus SD. And let's get some space there. And then the error bars, as I noticed, are behind the lines. So we want to call geom error bar before geom line. And so now we get our error bars behind our lines. Their error bars, of course, are black. Ours are the same color. And so in here, inside of geom error bar, I'll go ahead and do color equals black. And so now we've got those nice error bars. I'm going to hold off on doing any styling with all this because I know I will come to regret it. Let's go ahead and put in the labs. So our x is going to be time in hours, and that needs quotes around it. And then y is CFU per mil. So we'll do CFU per ml. It's a unit. I don't like having units as titles for axes, but hey, what can you do? I'm going to go ahead and put the legend on the bottom like they do here. And so let's go ahead and add to this theme classic, which will give us a nice clean background. And then theme, and we'll do legend.position equals bottom. And this then, of course, moves our legend from the right side down to the bottom. It has a title for the legend, which I don't care for. So we'll go ahead and do color equals null in the labs function. And so now we have our mutant arabinos, and a PA01. We can go ahead and change those colors a bit. So we'll do that up here. I'll put that under labs. I'll do scale, color, manual, and then breaks. And this is going to require a lot of typing, and I don't type very well, as you all probably know too well. So if I take Fig2C data and I then do a count on strain, I will get my strain names, okay? So I'm going to go ahead and put that up here in my breaks in quotes, and I'm going to put it in the order I want it. So we have PA01, we have the mutant, and then we have the mutant arabinos. The mutant arabinos is the complemented mutant, right? And then we need values, and the PA01 was in black, the mutant was in pink, and the mutant arabinos was dark red. So that did flip the order of my labels in the legend and gave me the colors that I want. So that's all great. We can also in here then go ahead and put in the labels that we want. So we'll do labels C, and this is going to be PA01. Actually, that should be PA01, not PA01. We say 01, but it's a 0. Anyway, and then we have the mutant. And the mutant is this monstrosity. So I'll go ahead and probably toggle back and forth. So I'll do D, ISCU, P era, ISCU. All right, so that's not exactly what it is, but close enough for right now. So I'll then copy that down, and then that's going to be plus 0.5% arabinos era. And so if we run that, we then get these labels across the bottom. I would like to put in this label here, though, HTML. And so what we'll do will be legend.text equals element markdown. And to use element markdown, we also need to do library ggtext. And so again, element markdown allows us to use markdown or HTML code in our labels, in our text for our legend. And so if I take this like this capital D, that's supposed to be a delta, capital delta, that we can do delta, semicolon. And so this ampersand delta semicolon is HTML for a triangle, or the delta character. And so sure enough, now you see my delta down here with the ISCU. And so let's go ahead and incorporate the rest of the markup. So the ISCU should be italicized. And so we can use a star on either side of that, and that will make ISCU italicized. And so now we see ISCU, sure enough, is italicized. And there appears to be a space between the U and the P. So let's go ahead and put that in. And then the era for Rabinos is going to be subscript. So we'll use HTML for that. And so now our era is subscripted. And then our ISCU, again, needs to be italicized. And we're going to go ahead and I'm going to copy this down below here for our third condition, the complemented condition. So the way this mutant works, as I understand it, is that they knocked out the ISCU gene, and then they added it back behind or with a promoter behind it that's inducible when you add a Rabinos to the media. So if you add a Rabinos to the media, then the ISCU gene goes, right? So I lost my PA01, and I'm noticing I've got a gray line here, which makes me think when I change that O to a 0, that incorporated problems. So let me come back up here, and let's see. I had PA0, not 0. So let's go ahead and try this again. There we go. Now we have our PA01 back. All right, so we've got our colors. And again, what I'm trying to do is build out each plot separate from all the other plots. And then we can make a function for this, and we can run it 4 times for each of the 4 drugs, and then compose it together using something like patchwork. So if you lost the track, that's where we're going. Okay, so the next thing I want to take on is the log scale on the y-axis. We'll come down here, and we'll do scale y log 10. We now have our y-axis is log scaled from 10 to the 3 up to 10 to the 7. But these values for 2 and 3 hours are below the limit of detection, right? Which had been 500. What we want to do then is change our scale y log 10. So we'll do limits from 500 to 1e to the 7. What we see then is that it dropped those points, and we got a warning message. And so I think I want here then my limits, I think I want to move that down below to a chord Cartesian. Chord Cartesian will keep the points, but it will clip them. It won't show them. And so it'll show a line going down to those points below our limit of detection. So then this should be ylim 500 to 1e to the 7. Get a plus in there. Now you can see that we have the scale. We don't have the warning message, but it's still showing the data there. And I think that is because we have expand on our data. And if we look at the original plots, there's no expand. In a typical R plot like this in ggplot2, it puts kind of a padding around the data on the left and right side of the x-axis and bottom and top of the y-axis. So we can get rid of that all the way around in chord Cartesian by doing expand equals false. And so now we see that it's using 500 as the bottom and 10 to the 7 for the top. There is no padding. There's no padding on the left. There's no padding on the right. And our data goes down below that 2-hour mark on the x-axis. And so that's looking good. The other thing that we can throw in here then are the breaks on the y-axis, the major tick marks, if you will. And so they go from 500 up to 5 million. And so we could do breaks equals. So I'm going to do 5 times, and I'll make a vector of values. So it'll be 1e2, 1e3, 1e4, 1e5, 1e6. And so now we see that we've got breaks on those increments and going up not quite to 1e to the 7. And we can then put labels on this to make them nice. So they'll be like 5x 10 to the whatever as they had here. And so we'll do labels equals. And I'm going to use the glue function from the glue package to do this. So I'll do library glue. And in here then, what I can do is in quotes, I'll do 5x 10, and then we'll do sup for superscript. And then I'll back out of that superscript. And what goes in between, so what we're superscripting then is going to be put in curly braces, and it's going to go from 2 to 6, okay? So we run that, we then get HTML formatting for our y-axis labels, which of course we can get to be rendered with HTML using element markdown. So we'll then do axis.text.y equals element markdown. And so now you'll see that we have the formatting very similar to what they had in the original figure. So the next thing I want to do is go ahead and put on those grid lines. And we can do that again back down here in theme by doing panel.grid.major. And actually I want the Y ones, because if I do major, I'll get both X and Y. So let's do Y. And we'll do element line. And let's do color equals gray. And so that gives us our gray grid lines. And that looks pretty good. And so now what we want to do is incorporate these minor tick marks. And we can do that by coming back up to scale Y log 10. And in previous episodes, I've talked about using the guide argument to our scale functions when we want to use, say, a different color or a different shape or different size of shape or different thickness of line. We can use guide, and then we can use guide legend and override AES, right? And so if you think about it, an X and Y axis scale are kind of like a legend, right? They're telling you the position on the X axis or the Y axis, just like a legend for a color is telling you the color that corresponds to different things. And so there are different guides that are available for working with scale Y log 10. And what we're going to use is this guide axis log ticks that will add tick marks at intervals in log 10 space. So let's go ahead and run this. And now what we see is that we have tick marks, right? We have those intermediate tick marks for our y-axis. And so something that sticks out to me that is a little bit weird, actually it's a lot weird, is that their labels, or like say 5 times 10 to the 5 here, is corresponding to the 10 position, right? So if you think about like this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But they've got 5 times 10, right? So that 5 should be kind of like where we have it here, right? So if this is the 1 position, this would then be 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So at this point, I'm not really sure what to do. I feel like this may have been a mistake on their part, how they labeled the axes. I don't think it changes this overall story, so I'm not claiming any impropriety there. I think what I'll do is get rid of the 5 times and instead label things at the 10 mark, at the 1 mark, right? And so why don't we come back up here and we'll edit this to get rid of that 5 times, and I'll get rid of the 5 times here as well. So let's go ahead and run this and see what that changed and what still needs to be changed. And I think that actually does pretty decently. So I think it actually looks okay to have 10 to the 3, 10 to the 4, 5, 6, and then 7 is not labeled up here at the top. I think they left theirs unlabeled up at the top as well. One thing that you'll notice is that the major tick mark is longer than all the other tick marks, whereas, and that's certainly the case for us, but that we have a middle tick mark that's of different length. And so if we come back up here to this guide axis log ticks, I believe that in here there's mid, short, long. And I think if you look at the documentation, at least from the pop-up I saw earlier when I was typing this in, we had long, mid, and short. And so I want my mid and my short to be the same length. And maybe I'll go ahead and make those short the same length as the mid. So I'll go ahead and make short equal to 1.5. And here we'll then do short equals 1.5. And actually, I'm going to go ahead and put in all the values. So I'll do mid equals 1.5 and long equals 2.25. And the reason I'm going to do that is because when I start putting the 4 panels together and kind of moving things around, I might want to start playing with the length of those tick marks to make sure everything looks good. Now what we see is that we have uniform length of our tick marks and that the major tick mark is longer than all the others. The other thing that I've noticed is that the y-axis text is a gray color rather than black. You can kind of see the difference in color there, as well as for the X. So let's come back in here to axis text Y, and we'll do color equals black. And we'll do the same thing for the X-axis. I don't need it to be element markdown, but who knows? We'll just leave it as element markdown anyway. Again, that turns everything to be black. So one last thing I need to add to this is a title, and the title was included to indicate the drug. And so back up here in labs, I could put in here title equals gentamicin And so now I have gentamicin as my title, but I want it to be right justified. And so you'll notice that gentamicin on all these are right justified, but there's a bit of a margin on the right side, right? And so let's go ahead and come here and we'll add to this plot.title equals element text. We'll do hjust equals 1. That should get it to be right justified. Yep, that's right justified. And then we'll do margin equals margin. And we'll do r equals, let's say 20. And that brings it over a little bit to the right. I'm not going to play with that too much because, again, I'm dealing with this in a very zoomed in scale. And when I put all the plots together, I'm probably going to want to move things around. And so I don't want to take lots of time nitpicking with these details at this level. So now this is the plot for gentamicin. What if I wanted to do colistin? Well, what you might think about doing is copying all this code and then changing gentamicin to colistin throughout. But that wouldn't be dry. Dry stands for don't repeat yourself. If you imagined me modifying this margin, if I had this chunk of code repeated 4 times, I'd have to repeat that 20 or 30 or whatever I change it to 4 times. And I am not that good. I am very prone to typos and mistakes. So what I'm going to do instead is make a variable I'll call drug name, and I'll call that gentamicin. Get that loaded. And then I'm going to take my drug name variable, and wherever I had gentamicin previously, I'm going to plug in drug name. And so I think I had it one other place down here in the title. Paste that in, running this, I now get gentamicin. And if I were to say do colistin, I then get the plot for colistin. So now we need to turn this into a function so that I can basically call this plotting routine for each of the 4 drugs. So I'll say plot drug data, and we'll make a function, and then we'll say drug name. And then we'll wrap this all in curly braces, and we'll go ahead and tab everything over 1 so that it's nicely indented. Close out that curly brace. And again, I'm going to grab this drug name line here on line 53 and bring it down, and we'll do plot drug data, and then I'll put in gentamicin, and I think I need to load this function still, and then if I run the function, I get my plot, right? And I can repeat this 4 times, and I think the last one was colistin, and the other was ofloxacin, so we'll do ofloxacin, and then the third was meropenem, and so if I do gentamicin, ofloxacin, meropenem, colistin. Cool. And so now I can assign these plots back to variables. So I'll call this gentamicin. And then we'll do ofloxacin. And then meropenem. And then colistin. And so if I run these 4 lines and say I were to run ofloxacin, I get that plot, right? So I'm assigning the plot to a variable. Now I'm ready to put these 4 plots together in a single figure. To do that, we're going to use another library that's called patchwork. The syntax for patchwork is pretty simple. We can do gentamicin, vertical line, ofloxacin, and then that is going to be 1 row, right? Gentamicin and ofloxacin, I run that. I see those are on the same row. I see that I've got both legends. Don't worry about that. We'll come back to that in a minute. And then we can then do division, and then we'll do another row, which will be meropenem, vertical line, colistin. You'll see that we now have our 4 panels in 1 figure. I'll then add to this patchwork plot underscore layout, and I'll then do guides equals gather. Yep, and it's not gather, it's collect. So this is looking pretty funky, and again, I think it's because I'm zoomed in so far. I'm going to go ahead and save this. We'll do ggsave, and I'm going to call this iron sulfur resistance.png. And I looked at the aspect ratio, and so I know that I want my width to be 9.87 and my height to be 8. So it went ahead and put my legend on the right side rather than on the bottom. And so I think that might mean that I need to adjust the legend position to be down below. And so if I want to change that, I can add an ampersand and then theme. And I'm going to go ahead and take out of all this my legend position to be on the bottom. And I can remove that extra comma. So we have to reload our function because I removed that line from the theme. So I'll go ahead and highlight and run everything. So now what you can hopefully see is that the landmarks are all in the right place, but the formatting needs a bit of help. So let's start with changing the font size on our legend. We'll come back up into our legend text. Let's do size equals 18, and that gets it to be a bit bigger, and that looks pretty good. So there's a bit of a margin on the bottom that I don't see on theirs. What we can add to our theme here then might be legend.margin equals margin. On the bottom, if I put 0, I think that's what the default already is. So I think that brought the plot closer to the legend, but didn't really free up that much space on the bottom. So if we do t equals 20, then we get more space between the legend and the bottom of the plot, but we still have that gap there, right? And so in these cases, what I commonly will do would be a negative number. So if we put the bottom to be negative 20, well, that's too far down, but you get the idea, right? Minus 10. And so that brings it up rather nicely, and that all looks pretty good. Let's go ahead and make our lines a bit thicker. Their lines, as you can see, are quite a bit thicker than my lines. And so we can adjust that back up here in geom_line. Let's do line width equals 1.5. And that's thicker, but still not as thick as theirs. So I'm going to take that back up to 2 from 1.5. And I think that looks similar in thickness to their lines. I'm noticing that my key lines are pretty short compared to theirs. So again, I can modify that. I'll come back up here and I'll do legend.key.width. And we'll do unit, and let's do 20 pt. And so that got it longer, but probably half the length of what it needs to be. So let's go ahead and take that up to 40. And that is about the same length as theirs. But as I've commented on other episodes, the distance between the key and the text on the left side is the same as on the right side. And I want to have more spacing, kind of like they have in this version. And so I'm going to add some margin to the right side of the text. And so back up here in legend text, we can do margin equals margin. And on the right side, let's put 30, and that should work. And so yeah, that gets us some pretty nice spacing between our different key elements. It's probably a little bit too close on the left side. So let's go ahead and make the margin on the left. Let's make that 10. Great, I think our legend is in good shape. Now let's move upwards and let's think about our labels on the X and Y axes, as well as the text. It appears that all the text in the plot is the same size, and it's similar in size to my legend. And so I think what we did for the legend text, was size 18. So on our axis text Y, let's go ahead and do size equals 18. And I'm going to copy this for the axis text X. And then we'll also do axis.title.y equals element text size equals 18. And put a comma there, and I'll copy this down to do axis title X. So good, that gives us larger text that I think largely agrees. We could probably also change the title to be the same size. So let's go ahead and grab this axis title X syntax, and we'll change this to be plot.title. Oh, it looks like I've got plot title in here twice, right? Because I did muck with the justification. So that was down here. So I'll go ahead and add size equals 18, remove this line 89. Let's try that again. And that all looks very nice. All right. So the tick marks then on the X axis are very short and very close to my numbers compared to what they had. So what we can do is come up to, I'm going to maybe sort this stuff to have all the X's together and all the Y's together. So we'll do that. Okay. And then here I'll do axis.ticks.x or .length.x, and that's going to be a unit. And then let's do 8 pt. Again, I don't really have a good feeling for how big those ticks are. And so those seem a little bit long. So let's maybe knock that down to 5. Okay, that's good. So their lines and ticks all seem quite a bit thicker than mine. So I can do axis.ticks equals element line. And we can do line width equals, let's say 0.5. Let's see what that gets us. So that didn't change anything. Maybe it needs to be 1. So let's try 1. And that gets it to be, I think, a pretty decent thickness compared to what they had there. Our lines on the axes are also thin, so we want to adjust that. So let's go ahead and do axis.line equals this element line. And we'll get rid of that extra space just because it's sticking out and annoying me. And that gives us a nice thick axes, which I'm happy with. I think that looks great. So something I'm noticing around the plot is that the plots themselves, left to right, are pretty close to each other compared to what was in the original. And so let's go ahead and add a margin around each of the plots. So we'll then do plot.margin. We'll do margin. And then on the right, let's do 20. So what I'm noticing is that it puts a margin into the right of the plot on the first column, but also the right column. And I only want it on the right of the first column. And so something we could do would be to go ahead and cut out that plot margin statement. And then I'm going to come down and, yeah, I've got these in the right order. So I'm going to go ahead here, and to the right of my gentamicin, I'm going to go ahead and add a theme with the plot margin, okay? And so we can add theme elements to each of the plots that's different between all of the other plots, right? And so we'll go ahead then to add that there, and then also to the end of the meropenem, because meropenem is the first column of the second row and gentamicin is the first column of the first row. So let's go ahead and try to run this and see if we get a space only between the two columns of plots. And sure enough, we now have a space between our two columns of plots and nothing on the outsides. So that was 20. Let's go ahead and up that to say 40 because they have quite a bit of space in between theirs. So I think that looks pretty nice. There is a bit of space, I'll note, between the two rows, right? And so I think what we could also do then is add margin to the top, right? So we'll do the same thing then with meropenem, where on the top, I'll do 20. And then I'll go ahead and grab this text, copy and paste it down from gentamicin to colistin to make the top 20. So let's go ahead and run that and now see if we get space between the two rows. And sure enough, we now have a space between the two rows, but not at the top, okay? So I'm noticing a couple things as we do that my legend at the bottom here is getting pushed down further. But before I mess with that, I want to play with the margin on my axis labels. The original had space between the number and the tick. And so let's come back up here to axis text X, and then I'm going to put in margin equals margin. And then at the top, let's put 10, and that added space. And that I think is a pretty healthy amount of space. There's also a space between the time hour and the time. So again, we can do the same type of thing with axis title X, and I'm going to copy what I've just put in for axis text X for axis title X. And so that then gives us some nice space between the title, the number, and the tick. Very good. And then I noticed that my legend kind of got pushed off the bottom here. So I'll come back down to where I had this bottom minus 10. And let's do minus 8. And then that gives us some breathing room on the bottom there. So the final thing that I'm noticing is that my error bar staples, that's the horizontal piece of an error bar, the staple, is really wide. And it's also quite thin. So we'll come back up here to geom error bar. And let's do width equals 0.2 and line width. The thickness wasn't the same as it was for geom line. So let's go ahead and make it 1.5. And that is about the right width of the staple, but it is kind of a thicker line. So maybe we can back that down to 1. And that looks pretty nice. So on the whole, I'm pretty happy with the way mine turned out. There's one subtle difference between theirs and mine that I'm going to leave for you to mess with. And that is that the y-axis on mine doesn't cross at 0 on the x-axis like theirs does. So you really can't see their error bars for those 0 points. I have talked about how to do this in previous episodes. Basically what you might do is get rid of the built-in line and tick marks and everything for that y-axis and draw your own using annotate and probably geom vline. But I don't want to mess with that because I think this video has gone on long enough. I think this is kind of an artifact of plots that are made in Prism. I suspect that this original plot was made in Prism. This is not the way I would build this in R. I will show you how I would build it in R in the next episode. I'm pretty happy with my ability to reproduce what they had in their original figure. On the whole, I think it looks really good. There's some differences in the fonts that we're using that account for some of the differences. Also, this issue with the 5 multiplier on this log scale. Not totally sure what happened there. It seems a little bit off. The keys here was using patchwork to assemble 4 plots together. Each of those plots I made using a function. I was then able to manipulate each of those plots separately by adding margin or other elements that you might want to add to them by adding a theme function to the output of plot drug data, right? And then, like I said, we could go ahead and use patchwork to assemble that all together. So to get those tick marks on the scale y log 10 output, we used guide equals guide axis log ticks. My understanding is this is a relatively new feature that's been added to ggplot2 in the last year or so, and I think it's really nice. I don't know why we haven't been showing those minor tick marks on the log scale. I think it really helps to see kind of where you are. That naturally, I might think that like 5,000 would be right about where my crosshairs are there, but in reality, that's at about like 2,000 or 3,000, right? That's not 5,000. That's a bit further up. And so I think it's nice to have those minor tick marks, especially with a log scale, where our eyes are really horrible at interpolating on a log scale. They're kind of bad on a Cartesian scale, on a linear scale. They're much worse, I think, on a log scale. Let me know what you think about this. In the next episode, I will show you another way of doing this, which I think is a more R-friendly or R-native way of building the plot. So that you don't miss that episode, please make sure that you subscribe to the channel, and I'll see you next time for another episode of Code Club.